All right, so we're now moving on to our last section of the year, and that's going to be section 7E, and we're going to talk about samples and populations. This is going to be done in two separate videos. In the first video, we're most likely just going to talk about the first three learning objectives. So students will know what a population is, students will know what a sample is, and then students will know what a random sample is. And then after we go through those, then that's probably where I'm going to stop that video, just for make sure it's not too long, and then we'll go into the last two learning objectives, which will be know the difference between a biased and unbiased sample. And then you'll have to be able to use a sample to make predictions. All right, so this is what we're going to be doing in our last video for the year, samples and population. All right, so first we need to know, well, what is a population? And a population is an entire group of people or objects. So it's what we're focusing on of the entire group, all right? So it's the entire group of the people or objects. So if we want to talk about our school, we can say that our population is our entire school body. And then a sample is a part of that population. So if we're talking about the entire school, we can then say, well, the middle school is a sample of it. So if we want to, our population could be the entire school. And then from there, we can say, okay, well, we don't want to look at the entire school. Let's just look at a little part of it. So we can then take the sample out, which is a part of the population. And we can say, okay, we're going to only focus on all the middle school students. Or we can say, okay, we're going to focus on homeroom 7A. The sample is a part of the population. And then a population is the entire group of people or object. And your population can vary in ways. And what I'm going to say now is like, at first I was talking about the entire population of our school. Well, we could just focus on just our middle school as well. And that could be our population from that, where we could just say, because the middle school is its own entity, we can say, okay, well, the middle school is our population. And from there, we're going to look at just the grade 6 students. And those grade 6 students could be our sample. Right? So the population kind of depends on how we're dealing with whatever data we're trying to collect or whatever we're doing. But our population, it's the entire group of people. So if we just wanted to focus on the middle school and then take a sample of that, our population would be the middle school, and then taking that 6th grade math class could be our sample. All right. So when we talk about population, that's the entire group of people or objects, and the sample is when we take a part of that group or of that population, and we're looking at that smaller part in general. And one of the things that you'll learn when you start taking statistics more and more is that we can take that sample, as long as it's not biased, which we're going to learn about, and it's random. That sample can actually, when we get data from that, it actually allows for us to then make, as it says, we can use a sample to make an inference or conclusion about a population. So the information we get from the sample, we can actually use it to then say, well, what would happen with the entire population? All right. So that's why, because if we were going to do a questionnaire for everyone in Hong Kong, that's a lot of people that we have to then would have to do a questionnaire with. So what we can do is we can take a sample of that population of Hong Kong and give the questionnaire to just that sample. And as long as it's not biased and as long as it's random, we can use that information and data that we get from that smaller sample and say, well, this is what the population would have as well. So that's why we need to be able to understand these samples, biased and unbiased, because we can actually use that to then make a conclusion about the population. All right, so now we're going to go through some examples to try to identify the population and the sample. Anything I highlight in yellow, it's going to be our population, and anything I highlight in green will be our sample. So identify the population and sample. So for A, we have the students in the school and the students in the math class. So we're always saying, when we're trying to identify which one's a population, which one's a sample, we can say, well, which one makes up the other? Meaning, if I wanted to pull a group from somewhere, could I pull the school population from a math class, or can I pull a math class from a school population? So whichever one you can pull from the other group is your sample. So in this case, the students in the school would be our population, and the students in a math class would be our sample. Think about it as being a subset, if you know what that means, meaning that we can pull a set of kids or things or items from the other one. All right, so now for this next one, we have grizzly bears with a GPS collar in a park and grizzly bears in a park. So you see the one on the right, it's all of the grizzly bears in a park, where the one on the left, we're looking at a very specific case. We're looking at only the ones with collars. So since there will be grizzly bears that don't have collars, that means that our population would be all of the grizzly bears in a park. And then our sample would be the grizzly bears in the park that have the GPS collar. Because when we're taking a group of bears, grizzly bears from another group, we would have to, since every single bear doesn't have a collar, that means that the bigger group of our bears will be all of them in a park, and then the collar ones will be the ones that would be our sample. For C, we have 150 quarters. We have all the quarters in circulation. Well, once we see all of them, that tells us that's our population, and our sample is just going to be the 150 that we take out. And then the same thing with the other one, all the books in the library, that tells us it's our population, and just picking 10 of those books in the library is our sample. All right, so it's really important that you're able to identify the difference between a population and a sample. All right, so now we're going to get started to talk about like samples and how to make sure that they're valid and what we should be looking for. And then also we'll get into biased and unbiased samples after this. But it's really important if we want to use a sample to make inferences or to make a conclusion about the population, we need to make sure that we're taking a proper sample. And just reading from here, there are many different ways to select a sample from a population. To make valid inferences about a population, you must choose a random sample very carefully so that it accurately represents the population. And the reason why it needs to be random is if I'm trying to, all right, let's just say, for instance, I want to talk about math at our school, AIS. And I, being a math teacher, if I am like, oh, okay, well, I wanted this to sound good. So maybe I might go and pick students that I know math is their favorite subject, and I'll start asking them questions about math. Well, that's a biased sample, and it's not at random. I'm choosing people that I think is going to help my cause or help what I'm trying to prove. So that's not random. If I wanted to get how people feel about math at AIS in general, I should be randomly picking people. And also randomly picking different grade levels, randomly picking females, males, like trying to get a representation of what the population here is at AIS. Because now when they're answering those questions, since it's at random, since it's not just being geared towards someone who I think is going to be answering it the way I want, then I can use that data to then talk about what maybe the whole school feels like. Because it is just a random sample. But once you start picking things that aren't at random and you're trying to purposely pick things, then it becomes a biased sample, which then means we can't use that to accurately represent what the sample is saying. For like same thing, if we're talking about sports and I'm questioning students here at AIS, well, if I just question only certain students who I know love soccer the most, well, that's giving me a biased opinion instead of talking about people in general about what their opinion is on soccer. All right, so we want to make sure that we're picking the correct sample so that way we can actually make decisions about the population or inferences that they're saying or conclusions about the population. So random samples, there's two things that we need to make sure. That we need to make sure that our samples are representative. It means that the sample includes only members of the population being studied. Right? So if we're talking about things here at AIS, I'm not going to go and ask students at other schools because they are not part of this population. So we need to make sure that who we are asking is part of the population that we would use that information to then make conclusions. It doesn't matter to me what a student at the Australian school thinks because that's not part of our school and that's not what if they hate or love math, it has no difference or I can't use that to then talk about AIS. Right? So it needs to be representative of the population and it needs to be random, meaning that every member of the population being studied has an equal chance to be selected for the sample. Right? We need to make sure that it's representative and also that they are equally likely to be chosen. All right? It needs to be at random. So if I want to talk about people who are who like sports, I just need to randomly pick students. All right. So it needs to be representative of the population, means that they need to be part of it, and then it needs to be random. All right. So this next activity is going to be able to identify random samples. So maybe you should pause the video and see if you can identify which ones are going to be random and which ones are not. So this way you can see if you understand this. So work with so when a sample is selected at random, each member of the population is equally likely to be selected. You want to know the favorite extracurricular activity of students at your school. Determine whether each method will result in a random sample. Explain your reasoning. Right? So will this A, you ask members of the school band. So is that a random sample? No, that's not. Because one, we're trying to find out favorite extracurricular activities. And maybe this is going to be something that we'll use to then say, well, maybe we should gear our school towards more of these activities. Well, if you're just asking about the school band, first off, you're picking a population, or you're picking the sample there, knowing everyone that's part of that band. And then you're also picking people that might have just the same common interests. And there's no randomness to it in that sense, because you are just going to that band. And you're not representing the population of your school necessarily, because there's different ECAs that people might like beyond what the band would like. So we would want to have a better representation of our school than just the school band. All right. You published a survey in the school newspaper. No, this one is not as well, because only the people who read the school newspaper will be the ones that answered that to you. So remember, everyone has to have an equal likely chance of being part of your sample. Back to that school band, not everyone in your school is equally likely because you chose that. Now, if you randomly chose a class out of the school to talk to, and that was the one that you randomly chose, then maybe we can talk about that a little bit differently. But everyone has to be equally likely to be chosen. So since you're putting in a school newspaper, not everyone reads the school newspaper. Not everyone has an opportunity to get it. Or maybe everyone does read it, but we don't know that for sure. So that one would be no. The next one, you ask every 8th student who enters a school in the morning. That one is yes, right? Because you are randomly picking the 8th person. We don't know the order of these people coming into school. And that changes daily. I'm sure, as you guys know here, your bus might be a few minutes late. Your bus might be a few minutes early. So it's not always going to be the same order every day. So we can't say, okay, I know how this order is going to go. So by me picking the 8th, I know I'm going to get the people I want. It's just pure random. Whoever comes in the 8th one, that's who we're asking. Same way when we do our Jeopardy question or Jeopardy game. I do randomly, whoever comes in, your group 1, group 2, group 3, it's all at random. I don't know the order that you're coming in, just like this person wouldn't know the order that they're coming in. So it is by random, and every person in school has an equal chance of being selected for that sample. And then you ask students in your class, and that one once again will be no, because outside of your class, especially the way our schools ran, you had the same class in every single class. So 7A wouldn't have a chance to be part of 7B's sample. So everyone in your population has to have an equal chance of being selected. So the only one here that is random is C. All right, and that is going to be it for this video of talking about random samples and population and how to make sure we're getting the correct sample. We're going to go to the next video to talk about bias and unbiased, as well as maybe using samples to then make predictions.